considered the data structure called as stack, and today we will go ahead with the second data structure, queue. Now we had brief introduction about this queue earlier in the last lecture, when we have said that in case of stack there is only one end from where the data will be added or removed. But in case of queue, it will be considered as a pipe, so that one end will be used for the addition of the elements and the other end will be used for the removal. So we will be talking about two ends of the queue, namely the rear end and the front end. Okay, one end will be for the addition and the other end will be for the deletion of the elements. Of course, we can very well check if when you are going to implement queue using array, we can very well check as how many elements are there in the queue, but that cannot be the purpose. Okay, we will be using some array as a storage. That is what we call it as implementation of queue using array. And as in case of stack, I had drawn it as closed at one end, whereas we have said that we will be adding the elements from here. Actually, it is not that the element actually proceeds in this particular direction. You will be directly adding the element, but you will simply say that now there is one element in the stack. Now top is at position 1, now top is at position 2, like that. So though the pictorial representation could be the element is added like this, as I am showing over here. Similarly, in case of queue, though we say that one end is for the addition and the other end is for the deletion as such, we can have some intermediate situation like this, when few elements have been added. So front will point to the first element in that particular queue. Okay, that means the oldest element in that particular queue, because it is going to follow the principle called as first in, first out. Front points to the position of first element, first slash oldest element in queue, whereas the rear is the position, or it will be the last filled position, as we have written it for the stack. So rear will be the last filled position and front is the position of the oldest element in that particular queue. So here this will be the element which has come before all other elements. That's why it has occupied a position over here. Then this was the next element which has reached, then this one, then this one, then this one. And then if we start processing, then we are going to remove this element and front will get incremented. Now the scope of the queue will be from this position till this. Logically, array is still the full one which we have allocated. Value which was there at position 0, which we have just deleted, that deletion happens to be the logical deletion, because physically the value will be still there. Only thing is, it is out of scope of the portion of that array which we are using as a queue. Okay, so physically the value is still present, logically it has been removed. The scope of the queue will be from position front till position rear. Whenever you add the element, obviously rear will proceed to the next position, even rear will be incremented. So for addition you will have to increment rear and place the value. For deletion you will have to remove the value from position front. You will have to remove the value from position front. So I am removing the value and then increment front.